So this video will go over section 2.2 on the structure of the atom. So all elements listed on the periodic table are made up of atoms. An atom is the smallest particle of an element. And so atoms are the building blocks of all matter. But atoms are too small, way too small to see with the naked eye. Even with very sophisticated machines, it's very hard to see an atom down to its size. So atoms are, on top of being very small, they are composed of 3 subatomic molecules. And so we will go over what those 3 subatomic molecules are. The proton, with symbol P or P+, is found in the nucleus of the atom and has a positive charge of 1, just 1 positive charge. And its mass is 1 or about 1 atomic mass unit. AMU here represents the unit of atomic mass unit. So it's about 1. Then there is the neutron. Neutrons symbols are N or N0. The 0 reminds that it is a neutral molecule. It has no charge. The mass is very similar to the mass of a proton. It's about 1 atomic mass unit. And neutrons are also located in the nucleus. Electrons, symbol E with a negative sign. The charge is -1, so that's why we have that negative sign in the symbol. And the mass is very, very small. It's like 2,000 times less than the mass of a neutron or a proton, right? It's 0.00055, which is considered to be negligible compared to the mass of a proton and a neutron. And so in atomic mass unit, you can neglect the mass of an electron compared to protons and neutrons. Electrons are located outside the nucleus in what we call the electron cloud. So these 3 particles are inside the atom. And so the atom is represented typically by a sphere, or those balls we saw in the previous section. They represent the full atom. So the nucleus is like a dense core in the middle of the atom. So it is very, very dense because that's where all the neutrons and protons are located. And because protons and neutrons are the ones who contribute to the mass of an atom, it's very dense because they are located in that tiny core inside the center of the atom. And to help you realize how the size of a nucleus is really, really small compared to the size of the atom as a whole, you can visualize a baseball that would be your nucleus, and that baseball in the middle of the Yankee Stadium would be your atom. So you see the nucleus is really a tiny, tiny dot in a very vast volume. And so that volume is the electron cloud. The atom, the sphere-like representation of the atom is actually the envelope of the electron cloud. All that space, and it's mostly empty space, right? You have electrons roaming around in that volume, in that sphere that we call the electron cloud. And there is no mass there because electrons have a negligible mass compared to protons and neutrons. However, that's the most of the atom's volume. The electron cloud is representing like the atom volume. So the representation in this drawing here is really misleading because it shows a very big nucleus inside that circle that represents the atom. Actually, the circle represents the nucleus. The electron cloud is represented by that bluish cloud around the nucleus. But still, the nucleus is way too big compared to what its real size is representative to the electron cloud. So let's talk about charges, because we said protons are positively charged and electrons are negatively charged. And there is some basic knowledge you need to know about electrical charges. It's that opposite charges attract while like charges repel each other. What we mean by opposite charges, so a positive charge will be attracted by a negative charge. And like charges means both negative charges will repel each other, or two positive charges will repel each other. So that means if we think about the atom, the protons, which are positively charged, and the electrons, which are negatively charged, they will be attracted to each other because they are oppositely charged. But two electrons will repel each other, and two protons also repel each other. And so for a matter to be neutral, it needs to have the same number of positive charges and negative charges. So you can have molecules or atoms that are neutral at the condition that you have as many positive charges as you have negative charges. And then the whole, looking at the whole atom or the whole molecule, it can be neutral, even though it's made of positive and negative charges inside. So here, let's go over a learning check. So you will need to say if the statements are true or false. So please pause the video before watching the answer. So number A, the mass of an electron is greater than the mass of a proton. Is it true or false? That's false, because electrons have basically no mass. Their mass is negligible compared to the mass of a proton. The mass of a proton is about 1 atomic mass unit. Statement B, protons have a positive charge and electrons have a negative charge. And that's true. Protons are positively charged, electrons are negatively charged. Statement C, the nucleus of an atom contains only the protons and neutrons. And that's true, because the nucleus is made of protons and neutrons. The electrons are in the electron cloud. Another learning check. An atom has 20 protons. Determine if each of the following statements is true or false. Again, pause the video before watching the answer. So if it is a neutral atom, it will have 20 electrons, sorry. Knowing that it has 20 protons, is it true or false? Here it is true, because we said that for something to be neutral, you need as many positive charges as you have negative charges. And here 20 protons will mean 20 positive charges. And if we have 20 electrons, which means 20 negative charges, they will cancel each other out. And the atom will be neutral. If it has also 20 neutrons, its mass will be approximately 40 atomic mass unit. And here, yes, it's true, because the subatomic particles that contribute to the mass are the neutrons and the protons. 20 neutrons will make about 20 atomic mass unit, and 20 protons will also make about 20 atomic mass unit. When you add them together, it's 40 atomic mass unit. Electrons do not contribute to the mass. If it has 18 electrons, it will have a net -2 charge. And that's false. So if an atom has 20 protons, that means 20 positive charges. And if it has only 18 electrons, which means 18 negative charges, 18 of the positive charges will be cancelled, but we'll have 2 protons that are not cancelled out by an electron. So it will actually be a 2 positive charge, not negative charge. So from the periodic table, if you have your periodic table, take it out. It's necessary here. If you look, there is always a number above the symbol for each element. And that number is called the atomic number. The symbol for that atomic number is Z. And Z, the atomic number, represents the number of protons in the nucleus for that atom. So in the example shown here, lithium has 3 protons in its nucleus because of its atomic number being 3. And so every atom of a given element has the same number of protons in the nucleus. It's always the same for a given element. And different elements have different atomic numbers. So that means you can identify an element by its atomic number, because for each element you have a different atomic number. So if you're given an atomic number, you can tell which atom it is. And so a neutral atom has no net overall charge. So when you're given the symbol of an element, you know its atomic number from the periodic table, you know its number of protons, and if you're told it's a neutral atom, then you also know its number of electrons. Because for the atom to be neutral, it needs as many protons as it will have electrons. So Z can also be the number of electrons when we are talking about a neutral atom. So let's go through a learning check to see what this implies. Again, pause the video before you watch the answer. Select the correct number of protons in each atom. The nitrogen atom. So you want to find the nitrogen atom in the periodic table. Nitrogen is in the upper right corner of the periodic table, and the number above the symbol N is 7, which means that nitrogen has 7 protons. Sulfur. Sulfur is very close to nitrogen, down to the right, S, symbol S. The number above the S is 16, and that number is the atomic number. So atomic number 16 means 16 protons for sulfur. Barium. Barium, symbol Ba, is found in the lower left corner of the periodic table. The number above is 56, so atomic number 56 means 56 protons for barium. Another learning check to cement that. What is the atomic number of boron? So you will find boron on the periodic table in the right side, on the right side, on top of the staircase, and boron has the atomic number 5, so the solution is 5 for boron. What is the atomic number of iron? Iron, symbol Fe, is found in the middle of the periodic table. Atomic number 26. How many protons does a chlorine atom have? So chlorine has a symbol Cl. It's found in the right side of the periodic table. atomic number 17. So how many protons does a chlorine atom have? And here the answer is 17. It's the same as the atomic number, because the atomic number represents the number of protons. How many electrons does a neutral neon atom have? Neon, found in the right side of the periodic table, atomic number 10, will have 10 electrons if it is neutral, because neon has 10 protons, and to be neutral it needs 10 electrons. The 10 negative charges from the electrons will cancel out the 10 positive charges from the protons. Will an atom with 6 protons, 6 neutrons, and 6 electrons be electrically neutral? And the answer is yes, because for electrically neutrality, you need to look at protons and electrons. And here you have the same number, 6 protons, 6 electrons. Each proton will be cancelled out by an electron, and the overall atom will be electrically neutral. Here, the neutrons do not matter. Will an atom with 27 protons, 32 neutrons, and 27 electrons be electrically neutral? Yes, again, it will be electrically neutral. It's very similar to the previous question. The 27 positive charges from the proton will be cancelled out by the 27 electrical charges from the electrons, because we have as many protons as electrons, so it's neutral. Again, neutrons only contribute to the mass, not to the electrical charges. Will an Na atom with 10 electrons be electrically neutral? So Na is the symbol for sodium. Sodium is found on the left side of the periodic table, atomic number 11. So will a sodium atom with 10 electrons be electrically neutral? No, because if sodium has 10 electrons and 11 protons, sodium is 11 protons, 10 of the protons will be cancelled by the 10 electrons, but then one of the proton will not be cancelled out, and so it will not be electrically neutral. It will be positive 1. So that will be the charge of the sodium in this case. And that's the end of section 2.2.